Hi guys, we're going to start at the very beginning with set notation and sets of numbers. So let's get going. Now in maths, I want to start off at the outset by making sure you know that you cannot divide by 0, you cannot take the square root of a negative number, and you cannot take the log of a negative number or 0, okay? Now we're talking about sets, so let's do some set terminology. Set A in this example here is the set of numbers with a curly bracket. We've got the set of numbers 1, 2, 3, 4, 5 and 7. These are all discrete countable numbers, hence the curly brackets. Okay. Set B is the set of numbers 2, 6, 7 and 10. Now 7 is an element of A, so this means that 7 is in the set A, or is an element of. This one here means that 9 is not an element of A, with a little oblique stroke through it. Okay. Now what's this mean? It means that the set of numbers 2 and 3 are wholly contained within the set A. Okay, here's A up here. Can you see that? Definitely. Okay, got it. And 2 and 9, the set 2 and 9 are not wholly contained within A because A doesn't contain 9. You got it? This is the null set, which means there's nothing in it. Now, intersection in plain English means and. We've got a bucket turned upside down, which indicates a small amount, okay? This U is the union, which means what is in either, okay? It's a bucket upright, so it can hold more, okay? That's a little nifty way of remembering this, yeah? Intersection, union. This little thing means except, okay? So what we've got here is we can have all elements in A except if they're in set B, and that would give us the remainder of 1, 3, 4 and 5 elements in the set A. Okay, we've excluded those which are also in set B. B except A would be just 6 and 10. Okay, pretty easy, pretty easy. What do we got here? Common sets of numbers. Okay, we've got the real numbers, which is all numbers that we know of. We've got the naturals, which are the positive whole numbers starting from 1, not including 0. The integers, which are all whole numbers, the positives, the negatives and 0. They're capital Z is the way you denote those. The reals are capital R, the naturals are capital N, integers capital Z, and the rational numbers, which we denote with capital Q, are any number which can be written in the form P over Q, where P and Q are whole numbers, okay? E.g. 2 over 3, 5 over 7, minus 8 over 9, whatever, okay? Okay, so here we've got the sets of numbers, okay? Now, what we've got here is the naturals. Then we've got the integers. The naturals are a subset of the integers. The integers and the naturals are a subset of the rationals, and the naturals, integers and rationals are all subsets of the reals, okay? There we go. There's some naturals for you. There's some integers, and as you can see, the naturals are a subset of the integers because they are whole numbers after all. The naturals and the integers are subsets of the rationals because you can see that these are really fractions, aren't they? Just over 1. Yes? Very good. And we have the naturals, integers and rationals are subsets of all of the reals, all of the rest of them which don't fit into these inside circles or ellipses as they are. You could also include in here Mr. Pi and Mr. E. You'll run across Mr. E in a great amount of detail as you get into exponentials and logs, all right?